In today's demo, I'm going to use three different clusters. The first one I'm showing you is the ACM hub or the manager. The whole cluster is dedicated to managing Kubernetes or Openshift clusters. The second cluster I'm going to use today is an Openshift cluster, which is to be managed by ACM. And then the third one is my home hybrid cluster, Kubernetes clusters. You can see there are actually 4 nodes, and one of them is an ARM node. The rest are AMD or Intel nodes. Let's have a look. Oh, by the way, I'm using this K command, so I'm too lazy to type the whole word kubectl or kubectl. So what I'm doing is I'm using an alias. So you can see that K is an alias for kubectl. So I'm going to show you which one is the ARM processor or ARMed node. Let's do a K get nodes. Say the first node, if you have a look, is an AMD 64 cluster. AMD 64 node. The only node that is an ARMed processor is node 1. You can see that is ARMed 64. So later on, I'm going to show you how I'm going to deploy applications on the AMD nodes, and also how to deploy applications onto ARM-based nodes using the ACM or Advanced Cluster Management for Kubernetes. Now let's switch over to the Acm Console. You can see there are a number of options that you can use. So the first one is end-to-end visibility, cluster lifecycle, application lifecycle, and governance, risk, and compliance. But before we can use any one of these other three, first of all, we have to actually tell ACM which clusters to manage. And to do that, we are going to use the cluster lifecycle. Let's click on it. Right now, ACM is not managing any cluster. So what we want to do is want to import a cluster. So first of all, I'm going to import that Openshift cluster. So what I'm going to do is say my Openshift cluster. Let it auto detect. And the environment is, well, you get a choice of either development port or QA. Let's just say dev. And you can add additional labels. I'm going to add a label called cluster. So why I add this label, it will be a little bit clear later on when I'm trying to deploy the applications onto the cluster. Now let us generate a command. So it's generating the command. Let's wait till it finishes. Now it's done. So you have to copy this command and run it on the cluster that is to be imported. Now let us get to that Openshift cluster, and let us see what we are logging in. OCAM. Who am I? I already logged in as a system admin, so I can run that script. So we need to change it to OC. So it's creating a number of CRDs. So what is that gibberish is here? So I'll get into that later. Next, I'm going to import my home hybrid cluster to be managed by ACM. But before I can do that, I have to do something with my home cluster first, because right now ACM does not officially support the ARM processor, so it does not have images for ARM processor. In order for ACM to manage a cluster, it has to install the certain agents on the cluster itself. So we have to prevent those agents to be run on the ARM nodes, because obviously it won't work on ARM nodes because those are Intel images. So in order to make sure that all these agents will not be installed on the ARM node, I have to first of all do something with the home cluster or hybrid cluster. The command we're going to use is this. Basically, we have to create a taint. A taint is something to prevent nodes from deploying. Unless you get certain tolerations, a pod will not be scheduled to run on that particular node. In here, let's have a look at what we are saying in here. We want to create a taint on the node 1, which is the ARM node, based on this. So it has a label called kubernetes.io/architecture, and it's ARM64. If it matches that, you're not going to schedule any pod to be run on there. So I already executed this, so I'm not going to run it again. Instead, I'm just going to show you that indeed the taint has been created on it. So what I'm going to do is this. You can see that for this particular node, it has such a taint created. Now we can proceed to do the same to import that cluster using the Acm Console. Let's do that. Cluster. I want to import another one. Call it my hybrid cluster. So it's a bare metal. Environment again is dev, and I'm going to add some labels in there. So I'm going to add cluster equals hybrid, and also ingress equals traffic. So why do I add these labels? The purpose of these labels will be apparent later on when I trying to deploy applications via the ACM. So let's generate a command. Copy it. And then I'm going to run that command on my hybrid cluster. So I'm just going to run it. And it will take some time to actually download and run all these agents. So I'll take this time to go through exactly what this gibberish is all about. This is the generated script. So if I scroll down, you can see there are actually two scripts in here. So in order to have a look at what it is, what I have done is that instead of passing it to the kubectl, I just redirect it to a file, say file1.yaml or something like that, and then have a look at it. So I have already decoded this file. Let's have a look at what is the content of this file. So there are two of them. So the first one, if you have a look at it, is actually defining a CRD or custom resource definition called clusterlet. So clusterlet is a controller deployed onto the managed cluster. So its function is actually to deploy the registration operator and also install the cluster work agent. So let's have a look at the second script. You can see that it's installing the registration operator. So what is the registration operator? So the operator is responsible for launching the registration controller. And the registration controller is responsible for creating and reconciling the certificates signing requests between the hub and the imported cluster. So that means, well, they have to establish and verify each other's identity before allowing the connection of the managed cluster to be imported. And another major function of the clusterlet is also to install the clusterlet work agent. The agent is responsible to reconcile the manifest work and updating clusterlet. So the manifest work is another CRD for defining and executing jobs on the imported cluster. That means whenever the manager or ACM manager or hub has something to execute on the managed cluster, it goes through this clusterlet work agent. Now we understand what is going on when we want to import a Kubernetes cluster into the ACM hub. Now let us get back to the Acm Console to see the new imported clusters. Let's get back to the cluster. So we can see that there are two clusters. The Openshift cluster have 5 nodes. My hybrid cluster have 4 nodes, so it seems that it has been imported. Let's have a look. So it shows you some information regarding the typo. So it shows you that, wow, this is the console URL for the Openshift cluster, and the nodes, these are the nodes that make up that particular cluster. Now let us have a look at the my hybrid cluster. So there's no console, no default console for the Kubernetes cluster. So actually, when I'm using that cluster, I'm actually using Portainer for it. So let's have a look at the nodes. So you can see that these are the nodes that has been, well, that make up that particular cluster. So there's a master, and also there are the worker nodes, as I said earlier. So only the K3s node 1 is an ARM processor. The rest are all Intel machines. Next, I'm going to show you the ports that are related to ACM. So these are the ports related to ACM. You can find out about the names of these ports as well as the namespaces they belong to. The ACM cluster lifecycle capabilities is not limited to just importing a cluster. You can also detach or remove a cluster. You can create an Openshift cluster or delete an Openshift cluster. In the next video, I'm going to show you how to deploy an ARM-based application as well as an Intel-based applications from ACM to the managed clusters. So stay tuned.